Um, so we're given an array of strings of the same length words. So array of strings of the same length words. So words is an array of string of the same length. What does this even mean? Okay, so the name of the array, the variable is words, and this array contains strings. Forgot to set the timer. Clock 15 minutes as usual, and start. In one move, you can swap any two even index characters or any two odd index characters of string I. What does this even mean? In one move, you can swap any two even indexed characters or any two odd characters of a string. So in one move, you can swap any two even index characters or two odd index characters of a string, which is a member of the words array. Two strings, words I and words J, are special equivalent. If after any number of moves, words I equals words J. For example, if words I is ZZXY and words J is XYZZ, these are special equivalent because we may make the moves ZZXY and swap X and swap X and Y to give X ZZ, and then swap um, Z and Y to give X Y Z Z. Okay, a group of special equivalent strings from words is a non-empty subset of words such that every pair of strings in the group are special equivalent. And the group is the largest size possible. That is, there's not a string words I not in the group such that words I is special equivalent to every string in the group. Return the number of special equivalent strings from words. Okay. Now we want to return a group. Okay. So this a special equivalent string is a string where by moving indexes over and over again, you're going to arrive at a at two equal strings. Sorry, it's that time. You're going to arrive at two equal strings in the words array, right? But then a group of special equivalent strings from words is a non-empty subset of words such that every pair of strings in the group are special equivalents. Every pair of strings in the group are special equivalent. This means um non-empty subset. Okay. The group is the largest size possible. There's not a string words I. There is not a strings words I not in the group such that words I is a special equivalent of. I don't understand that. But what I understand by a group of special equivalent strings from words means a non-empty subset of words. That means like having um two or more parallel sequence of strings, right? A group of sequence from words is a non-empty subset of words such that every pair of strings in the group are special equivalent. Every pair of strings in the group are special equivalent, which means we are taking off a subset that every single pair of this subset is equivalent. They are special equivalent. I remember a special equivalent is at two strings, but that by switching the first, we are going to arrive by switching odd and even um, members of this string. We are going to arrive at the next string. So the group is the largest size possible. There's not a string words I not in the group such that words I is a special equivalent to every string in the group. I don't quite understand this. The group is the largest size possible. The largest size possible. There's not a string words I not in the group such that words I is there's a string in the group such that words I is special equivalent to every string in the group. Okay. I don't know what the second point means, but then let's go to the example. So I have words this, and this. The output is 3 because one group is A, B, C, D, C, D, A, B, C, D, A, B, because these are identical. Since they are all pairwise special equivalent, and none of the other strings is all pairwise equivalent to this, the other two groups are X, Y, Z, Z, and okay, so these are the other two groups. These are the two groups. Note that in particular, Z, Z, X, Y is not special equivalent to Z, Z, Y, X. Okay, so these are special equivalent, but not the longest group of special equivalents. So for this second example, we have ABC. If we move A and C, we'll have CBA. So this is automatically not going to work. And let's take this to BAC. If you move B to A, you have BCA. BCA. Okay, this is BAC. It's BCA. If you move this to, you have no. I think I don't quite understand, but let's take this out. First of all, let's take this out. So if you do this analogy, we are going to have, when you swap the first number, you're going to have okay, let's say we swap C. I'm going to have C B, sorry, C B A D, C B A D, and then if you swap again, you're going to have C D A B. Right, twice. You have C D A B, and then you have C B A D. Okay, these are the pairwise equivalents. Let's go back to read this. You're given an array of strings of the same length words. In one move, you can swap any two even index. In one move, you can swap any two even indexed characters or any two odd indexed characters of a string. Two strings with I or JI special equivalent if after any number of moves. Here it says one move. In one move, you can swap any two even index character or any two odd index characters. For example, a special group because we may make the move XXY, X and this. Now, after many moves, so I have some questions already for this, but let's see the hints. No hints. Okay. This is quite a tricky one, if you ask me. Okay, so how would I go about this? So how would I go about this? In this first example, we have A B C D. If you swap A B C D the first time, it's going to give you if you swap the even indexes, it's going to give you it's going to be C B A D. If you swap it the second time, the even indexes now is going to give you C D A B. Now, how do we know when to stop? How do we know when to stop? I think this is a very, very tricky question because how do we know when to stop? Because how do we know when to stop? This is a very tricky one, I'd say, and I don't even understand like the mechanisms of the question. The first question I have is, how do you know exactly when to stop? Like A, B, C, D, you're doing the first swap, and then you're doing the second swap, and then you're doing the I don't know, like how do you exactly know when to stop? Um um that's the problem. That's the problem actually. How do you know exactly when to stop the swap? In this case we swapped once, twice. And I see that okay, it is ZZXY, and then we swap the first one, which is Z and X. It turns to XY, XZZY, and then the second one we swapped this and this. And then I think after that swapping, we are done. In one, we can swap any two even index characters or any two odd index characters. This means if this even index, I can't swap even index here. Okay. 0, 1, 2, 0 and 2. I can swap 0 and 2. But then I can't swap 1 and X. So I just have to swap only once. This is very tricky. I mean, I would love to see the answer to this question. And the topics are arrays, hash tables, strings, and sorting. I mean, this sounds like an interesting question. And my time is about 1 minute. So when it elapses, I'm going to pause this streaming and try to, well, this is not a stream because my internet has been so bad lately. I'm going to pause this and try to, first of all, let me even take a look at the discussions. I'm sure this question is probably easy once you know what the hell is being asked. But after reading the script so many times, I'm giving up and trying to make sense of what is even being accomplished here. A really simple problem will cost me a lot of time to understand the description during the contest. Can someone explain to me why this test case? Okay. I don't really understand the question. Can anyone explain this in simpler terms than what is provided? A group of special strings from A is a non-empty. Yeah, my time is up. So I'm going to try to pause this and try to check the solution and come back. So the solution lies in the fact that we can sort the even and odd numbers together, and that would tell us the whole picture of the special equivalent. So in the first example where we have A, B, C, D, and let me take this out of here. In the first example, we have A, B, C, D, and we have C, D, A, B, and C, B, A, D. In the first example where we have this, if we take the first index, we can say A, C. These are the even indexes, and then we take BD and come to sort it later. It's going to be AC, BD, obviously. For the second one, let's say we take the even indexes and take the odd indexes also, and we try to sort them individually. It's going to be C. It's going to be AC, BD, which is the same. And then we are going to have a set that is going to collect this number and return the count for the set. So first, let's take this out of it. First, we loop through the whole array. First, we loop through the whole array. Second, we loop through the items or the string. We create new even and odd arrays with the string. We sort even and odd arrays, then bring them together, and then add the result to a set and return set.count. Yeah. So let's start from the first one. For x equals 0 and x less than words to length, we want to like increment also. So for this, we want to have another first we want to have the answer, which is going to be a set, const answer, which is going to be a set, new set. And the methods for adding items to set is like set.add. But for now, we want to have another okay, let's say word is equals words x. Now we want to loop through the items in the particular word index, the sentence, and we say for Let's still use like the for loop. Less than word dot length y. No, this is a mistake. Supposed to be y plus plus. Now, what we are going to do here is, remember, we are going to create um even array, an even array, and an odd array, and we are going to check if you're going to check if this index is even or odd. Let's have a variable to do that is even, and we are going to check this index, sorry, y modulus 2 equals 0. This means this is an even number. It's even. So if it's even, well, like an even index, even dot push word y, else or dot push word y, and then after that, after doing all that, we wait a minute. Okay, after doing all that, we have found, wait a minute, we don't want to, wait a minute. After looping through this one, we okay, this is looping through every word, right? And for each word we want to have even and, yes, for each word we want to have even and, yeah, and this is outside. No, this is inside. So this is the word and this is even, and yeah, okay. And then we, in this loop, we are to return or okay, concatenate even and odd. I want to call this sorted word. But first, let's sort the both. Even dot sort and odd dot sort. Let's sort both of them, and then sorted sorted what? Let's say sorted arrays. So sorted concatenation, and just plainly say even and odd. Let's say even and odd. Sorted concat even and odd. And then this is going to give us, yep. And after this, after like sorting or concatenating, we want to push this to the set. Let's call it answer dot add sorted concat, and then we just want to return answer, and let's run to see if it works. No, wrong answer. output not a number, answer dot size. Okay, so this is correct, and then let's try to submit and see if it passes all the test cases. Yep, and this works also. So it's pretty much the same the idea. We want to first sort the even and the odd indexes, because at the end of the day, for some reason, swapping these items in the string are going to give you the equivalent of a sorted um 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 even and odd index. So yeah, that's it for today. See you tomorrow.